So I'm going to pick up where we left off last week. We didn't quite make it through the milestone 1 walkthrough, so let's just finish that off and then we'll go on to code style. So if you remember what we were talking about last week, you completed one of the M1 functions, which was, let's see if we go back a couple of slides. It was this one, find street segments of intersection. So passed in an intersection ID, you had to return a vector of all the street segments. And we made that work, but it wasn't fast enough. So we talked about what could we do to make it faster, and basically we could preload data in load map. And that's where we are here. So we're in load map, we're preloading data. We decided that a good data structure would be a vector of vectors. Okay, for every intersection ID, we have to be able to return a vector that has all the street segment IDs that touch that intersection. And because we might get asked that question for any intersection, we're going to make a vector of those results and store them in advance. Okay, so we're going to do this inside load map. So load map already is loading up the lower level API that we need, and what we need to do now is do more than just load up that lower level API. We need to pre-compute this answer, this global variable intersection street segments. We need to preload it. Okay, so what does this data structure we're creating look like? Well, it's a vector of vectors, so it's a lot like a two-dimensional array. So the first dimension, we have one entry for every single index. So one entry for intersection 0, one entry for intersection 1, one entry for the last intersection, which would be num intersections minus 1. And for every single one of those intersection values, we're going to store another vector. And that vector is going to be the actual street segment IDs that are the answer, what street segments touch a certain intersection. So for intersection 0, we might have 3 intersections. For intersection 1, maybe there are 5 intersections that touch it, and so on. Okay, so this entry, once again, is for intersection 1, what are the IDs of all the street segments that touch that? Okay, so I think in the interest of time, I'm not going to do a breakout room here, but think about how would you code this? So I can give you maybe like 30 seconds or a minute to think about how you would code this. You can try typing it in a text editor. If you feel you've got something that you'd like to share, then go ahead and type it in the chat. Okay, and you'll need the functions that we were using last week, which hopefully you remember. And you'll also likely need this additional function, which our lower level API, the Streets Database API, provides, the number of intersections in a city. Okay, so I'm going to give you 30 seconds or so, and just, like I said, on pen and paper or in the chat window, just type in what you think the answer to this is. Okay, so I'm not going to give you too long here because we're not doing actual breakout rooms. Let's see, so the first thing we're going to do is we're going to make the first dimension of that vector. So remember the data structure that we're creating is basically got one entry for every single intersection. Okay, so that's what we just did with this line. This line made that first dimension. So we said, this global variable, intersection street segments, I've called this member function called resize. And how do I know there's a member function called resize? I go to c++.com and I look at the description of vector, and I see there's a member function called resize. And what that resize function has done for me is it basically has made this first dimension. So it sizes the vector to have one entry for every single intersection. And this is a 2D vector, so every one of these entries is really its own vector. It will be initialized to empty. Okay? So that's actually kind of convenient to create this first dimension all in one shot like that. So that's why I've used the resize call rather than a whole bunch of pushbacks. Turns out to be more convenient in this case because now all of the entries exist and I can just refer to them with the square bracket operator. So now what I do is for every single intersection from 0 to the number of intersections of the city minus 1, I'm going to go through and iterate. And for every one of those intersections, I'm going to say, tell me how many street segments touch that intersection, just like I did before. And then for each of those, say 4 street segments that touch one of my intersections, I'm going to say, tell me the ID of that street segment, and then I'm going to store it. Okay, so I do a push back. What do I push it back into? I push it back into the appropriate vector. So the appropriate vector is actually the vector associated with that intersection. So once again, I've got this first dimension. When I'm on intersection 0, all of these pushbacks are going here. Okay, so I might be making ID 301, 311, 321. Maybe those are the street segments that touch my intersection ID 0. This loop is putting them all in that vector. I go through this whole loop and then I'll go on to the next intersection. So the next intersection is intersection 1, and basically I'll start filling in its vector. So it'll get its own vector over here. Okay, when I'm done, I return this value, load successful. So if everything was good, I'm going to return true, saying it all worked. Okay, so hopefully that all made sense for you. Is all this pretty clear? This resize function might seem a little mysterious. I told you what it did. But again, the STL is huge, so if you forget, you go look it up on c++.com and it'll tell you exactly what all the member functions of vector are and how to use them. Okay, so we just did a whole bunch of pre-computation. We pre-computed the answer for every single intersection in our city. And so what do we do in this find function? So this is the function that's actually going to get tested by the unit tests or ECE 297 exercise that we wrote. So it gets passed in the ID of some intersection, and again it has to return the vector of street segment IDs that impinge on that intersection. Well, it's really simple now. We already computed this for every possible intersection we could be answered about, questioned about. So we just return that pre-computed answer. So if we're asked about intersection ID 0, we would return, this vector, the first vector. If we're asked about intersection ID 1, we would return that vector, second vector, and so on. So it doesn't get any faster than this. We pre-computed everything. We return the pre-computed vector with just one line of code. It's a single lookup and a return. Okay, how does that impact performance? We moved complexity to load map. So our load map got slower, but that's okay because load map is only called once when basically we start up our program for the end user. So we don't care too much about its performance. The speed tests for it are very generous. And now we've made that function that finds street segments of intersection much faster. So we pass it, and as I said, load map got slower, but it's okay. You're given several seconds for it, which is a long time. Let's see, so there's a question from Daniel, can load map be as slow as possible with no consequences? No, we do have a speed test on it to make sure you don't make it infinitely slow, because that would get annoying to your end user. Your program would never start then. But you're given several seconds, and the number is scaled by city size. So it's, not a difficult speed test. Basically, it allows you to do anything that is order n or a little bit more than order n. So you can look at all the data in the city a few times. If in load map you ever did something that's order n squared, now that's going to take many minutes, maybe even hours. That's going to fail. Okay, so don't do that in load map. But doing anything that's order n or a little worse in load map is going to be fine. Okay, so that's the end of the tutorial from last week. Any further questions on that or about milestone 1? Okay, if not, we'll go on to the tutorial for today. Okay. me flip over to today's slide deck. Okay, so I'm going to start talking about, I'm talking in the tutorial about this, we'll talk some about it in lecture too. What is good code style? And you look at the milestone 1 rubric, and there are some fraction of your marks which are assessed by your TA based on the style of your code. So you want to write good, readable code, and this is also going to make your team more efficient, because if you can read each other's code, then, well, it's easier to move tasks around, you're all going to get things done faster. Okay, so why does code style matter? Code is written once, but it's read many times. It's modified many times over its lifetime. This is particularly true in industry. So it's going to be somewhat true in this project, but it's more true when you go out into your future career. If you write code once and throw it away, that's not very efficient. So code usually lives on for a long time. Being able to read code is actually a really important skill. You in industry spend more time reading code than writing code, because you have to figure out, how do I fit into all this code that other people have written, and you want to make that as easy as possible. So we want to write code which is easy to read and easy to understand, not tricky at all. If code is instead hard to read, then it's bug prone. It's difficult for you or anyone else to reason about, what does this do, how does it work. It's hard to modify, because to modify code you need to understand it first, so it's difficult to understand, it's hard to change, and it's difficult to reuse. If your code's hard to read, first, people won't understand it, which makes it impossible to reuse. Even if they spend the effort to figure out what it does, they're always going to be worried. It's not very clear, and therefore it might have side effects that they don't understand, so they're more tempted to just write their own version. So your code's not as useful. At Google, for example, Google has very high code quality. All code that is put back in their source code control system, it's actually not visible and not used, so no one else can see it. It's not really committed, not available to anyone else until it is reviewed for style by someone, and it's also reviewed for essentially correctness by someone who understands the system you're working in. So they actually have at least 2 people, 2 different aspects of code review. One for, is this easy to read code, and one for, does this fit into the overall structure of the system you're in. I think it's a good philosophy they have, and it shows how important readable code is. They just make sure it can't go back unless it's been found to be readable. So today we're going to talk about some principles of code style, and so there are a few overall principles to keep in mind, and then some basic rules. How long should your functions be? How should you name your variables, and what should their lifetime be? So how much of your program should they exist for? How do you comment and duplicate code? There are lots of other things that can make your code style good or bad. We're not going to cover them all. We'll cover a few more of those in lecture. And this is like learning to write well. It's not something that you can do in just a couple of lectures. You practice as you're writing code and you get better at it. Okay, so guiding principles. You are trying to reduce the cognitive load of anyone reading your program. So programming requires understanding a lot of details. And there's a study, famous study done by Miller, that said that human working memory is about 7 plus or minus 2 items. So some people can keep a few more things in their working memory, what they're really thinking about. Some people can keep a few less, but it's not that many, 5 to 9 things. So if you make a big block of code with many variables and you need to keep a lot of information in your head, it doesn't fit the way the human mind works very well at all. People are going to find it difficult to understand your code. So you're going to try to fit into people's understanding, which means they can't keep that many things in their mind. Incidentally, this is why phone numbers are 7 digits. They did studies to say how many numbers could a person remember, and they can remember 7 pretty well, but they can't remember 11 or 12 or 13 very well. That's why the phone numbers are 7 digits long, and then you have an area code that isn't too hard to remember. You want to explain why. So if you write your code well, someone can read it and they can understand what you're doing, how the code works, but it doesn't explain why it's doing that. That's where your comments come in. giving that higher level context. So if you were there and you still remembered, you could explain it, but you're usually not around when someone else is reading your code. Sometimes, you forget too. I have written comments, many comments to myself, where I'll come back 6 months, a year, 4 years later, and I'm thankful for the comment because I don't remember why did I do it this way, what was I thinking. Okay, so let's look at some of these aspects of coding style. So functions. So short is best. If a function is longer than about 10 lines, it's not great, okay? There's no hard and fast rule of how long should a function be, but most programmers write them to be too long. So if you can keep them to 10 lines or less, or you can be a bit more, but in that range, then it's easier to understand your program. And the way that you usually get long functions is they grow over time. People might start off saying, okay, I'm going to have pretty short functions, but then over time, I'm just going to add a couple more lines to this function. I'm going to add a little more. And after a while, your function is too large. And long functions are just harder to understand, and they are harder to reuse because they usually do too many different things. So try to keep them short. If you're adding code to a function that's getting long, refactor it. So refactoring means you take some of the code that you've already written and you move it into a new function. Okay, it's getting too long, you make a new helper function, and now both the original function and the helper function are short again. So that's good. So yeah, I already said this, long functions are hard to read, they're hard to understand, and they're hard to maintain. The maintain is partly because they're harder to understand, and partly because they tend to do too many things. So that it's harder to reuse a function like that. Shorter functions basically name parts of your code. So you have to give a name to a function. So that's a form of documentation. These 10 lines of code have a name saying what they do. So people don't have to go and read all 10 lines of code if they just see a call to that function. They can often just read the name of the function and understand what it does. And functions are a key way that you're structuring your code for reuse. Okay, so variables. You want to use good names for your variables. So a good variable name describes what's in it and what it's used for. And the person reading it shouldn't have to go look at how you initialized it to understand its purpose. The name should be enough. You also want to minimize how many variables you have in scope. So in scope means active variables, the variables that could be used in a certain line of code. So I'm going to show you a couple of examples of this in a few minutes. You also want to think about how many temporary variables you want. So too many temporary variables where many of the variables are sort of renamed copies of each other can be hard to understand because you're increasing the number of variables that a person needs to keep in his or her head. On the other hand, so those are bad, temporaries that are really just copies of other variables. On the other hand, sometimes temporaries are good. If you have too few temporary variables, you might wind up with very long lines of code, and that can also be hard to understand. So temporary variables, if they're given good names, and they represent some kind of sub-step in what you're doing, they can actually help a person understand. So again, it's kind of like writing an essay or English. There's some craftsmanship to this. You have to look at too few temporaries can be bad, too many can be bad, so you have to kind of get used to what is easy for people to read. Let's see, I see a question from Dante. What does it mean when code smells? So code smells is just something people often say about that code is bad, right? So code works, but smells means I don't really like its structure. It feels like it's past its best before date. I wish we could rewrite it. Maybe we should go rewrite it. Okay, so I'm going to do a poll. So I'm going to give you, as I launch the poll, I'm going to give you a couple minutes to read this code, and I want you to rate what you think of its style. Based on what we just said and any other aspects of code style, any other aspects of what you consider, readable versus not very readable code. Okay, so you should see that poll now. Read through it, see how easy this is to understand, and you can vote on what you think of this. this is a piece of a function you actually have to write for milestone 1 as well. So understanding this code could actually be helpful to you. Okay, so maybe another 30 seconds or so to think about it. And yeah, think about why you think it's good or why you think it's not the best. And I'll ask you that in the chat too. Okay, I think that's pretty much everybody. So let's see what people thought. Okay, so hopefully you can all see the poll. So 10% of people thought it was perfect, 20% thought it was good, 45% thought it was fair, so significant improvements were possible. 15% thought it was poor, so hard to read and many style issues. Nobody thought it was terrible. And a couple of people are longing for Python. So you're going to learn Python for sure in some later courses. It is a useful language to learn. So you're probably not going to be able to only use Python, but it is a good language too. Okay, so my own personal rating of this. Well, let me ask Andrew. So Andrew, you're on the line. See if you're listening carefully, or if you're grabbing a coffee.
Yeah, I'm here.
What did you think?
So my vote for this was actually fair. Like significant improvements would be made.
So why'd you say? Well, maybe I'll ask other people. So you said fair, and that's the most popular vote. So most people thought it was okay, but you could do quite a bit better. So maybe I'll get people to type in the chat why. What is? Well, you can type what's good about it. If there's something you like, you can type what's bad about it. If there's something you think they could improve. And so Andrew thinks it's fair. I mean, I would have actually said fair is about where I'd put it as well. So you're pretty aligned with, I think, how myself and the TAs would grade this code. So I agree with you. Andrew agrees with you, but why? Comments? Yeah, okay. So lack of comments here. That's definitely true. So we'd expect to see some comments on this. No spacing. Yeah. So it's indented, okay, and not indenting properly is like, it's kind of like you wrote an essay and you didn't use punctuation or capitals. So we should never see somebody who doesn't indent properly. It happens, but it just shouldn't happen. So they've indented properly. They haven't actually got any vertical spacing, and that actually can make it hard to read the code. Variable names aren't descriptive. Yeah, that's inter 1, inter 2, so they're not the worst. At least they're not I, J, K. But they are inter 1, inter 2, lat long 1, lat long 2. Not that descriptive either, it's true. See a request for more indentation. Yeah, you could. I think this is only using 2 spaces. So 3 or 4 spaces is usually better. So that's true. Part of that is an artifact of trying to fit it all on the slide, to be honest. Let's see. There's a question about how much should you comment. So we'll get to that a little bit later in the tutorial. It's a good question. So Daniel's asking, should we comment obvious things? I guess to give you a preview of what we're going to talk about there, you comment what's not obvious. The why. Why am I doing this? Things that you can easily tell from just reading 1 or 2 lines of code, you don't have to comment that. But the higher level context of what is this function trying to do? Why is it doing it this way? That's very important to comment. Okay, so let's move on. So I agree with the comments people are making here. So let's see. This was a comment from Dante. No spacing. And yeah, they're not using vertical white space. Vertical white space is your friend. It basically lets you break your code into essentially paragraphs. It's like paragraphs in an essay. So break it into code that belongs together, that's doing some logical unit. That's exactly what a paragraph is for in writing essays. That's what vertical spacing is for in programming. So here's where we were. And if we put a bit of vertical spacing in, I mean, it looks easier to read to me. So I can kind of see this if statement standing out more. I can see these two lines, they kind of go together. It's just a bit easier to read. So hopefully you agree. Next thing, so one of the principles I gave you was trying to minimize cognitive load, trying to minimize how many variables are alive at any point in time. And this person is using kind of an older style of writing code. Basically, older versions of C, not C++, but older versions of C, you had to declare all your variables at the top of the function, and that was true in a lot of older programming languages too. It's not true in recent versions of C, it's not true in C++, it's not true in most other modern programming languages. You can declare variables just before you use them. So this person is declaring all of his or her variables kind of at the top of the function, and that's not the best practice because basically this length, for example, let's do it by example. So they've created this variable length, they've set it equal to 0, and they don't use it until down here. Okay, so when you're reading this subroutine though, if you want to know, well, what is length and is length used anywhere, you have to read the whole function because maybe it is used somewhere, but it's actually not used, it's only used in this very local region. Okay, and you can find many examples of this. So they also have these distance variables, and these distance variables are actually only used down here in the else clause. So why did the person declare them way up here and then they're not actually used in this if? They're just used down in the else? I don't know. Also, they were initialized way up here, so we said dist first and dist last equal to 0, and maybe this code relies on that, but there's basically a big gap. I have to remember that these have been initialized to 0 as I read through all this code and remember it here. Okay, so you've increased my cognitive load, you've increased the possibility for bugs. So it's better to declare these at what's called the smallest scope possible. So right before they're basically going to be used, you want to declare them. Okay, so if we do that, so now we can get rid of all those declarations at the top. We still have one. The street segment info is kind of used all over the place, so we still say fine, we're gonna declare that variable there. Let me get rid of this pool. Sorry. We keep this variable here because it's used everywhere. It's a logical one for function scope. But these intersection variables, lat long variables, these this length variable, we can declare them all right as we're using them. And now we can declare them and initialize them together. Before, we could only initialize them to kind of 0. There wasn't any real logical thing to initialize a lot of them to. Like, we don't really know what length is, so we'll just set it to 0. Now we can declare it and immediately initialize length to the right value. So that's less bug prone, trying to do your initialization and your declaration together whenever you can. And again, our names they're only used in a more local area. It's easier to keep this straight in your head. Okay, next thing. So this was commented on by Hannah, that the variable names aren't that descriptive. And yeah, they're not the worst. The worst would be, I do not use like I too. I mean, that's super bad. Okay, that's just going to enrage your TA when he or she's marking the code quality. So don't do that. It'll enrage your teammates too. It's really hard to read. So it's not the worst. At least it says it's an intersection, but it just says they're intersection 1 and intersection 2, which actually is less information than we had before. We actually knew which one was the from and which one was the to. We've got lat long 1 and lat long 2, and so again, we've lost some information. We don't know which one is from and to. Maybe that's not that important in this routine, in which case this isn't that big a deal, but if we actually need to know which one is from and to, then our variable names aren't great. This variable name is kind of particularly bad. We just called it ID. Well, we have lots of IDs, right? We have intersection IDs, we have street segment IDs, or lots of IDs flying around in this code, so this is a particularly bad name. We should find a better one than that. Okay? So yeah, we should have called this like street segment ID or something, or SSID. We also have a lot of temporary variables here. So probably more than we want. So these are temporary variables. This is a temporary variable. So we got a lot of temporary variables here. Let's just see what would happen if we had fewer temporary variables. Okay, so this is so basically change this name to street seg ID. That's a much better name. We could try to make these a bit better, you know, enter from, enter to, but it's probably better just to try to get rid of those temporaries. Let's see what that looks like. Okay, so let's look at all this. Yeah, so we've done a couple things. We've got street seg ID instead of ID, and then next we're going to go from info to seg info. Okay, so that's both those variable names are now more descriptive of what are they. And now let's, as I said, these temporaries don't do much. Okay, so I'm doing just a little bit of work to take seginfo.from and give it a new name enter1, and I take seginfo.to and give it a new name enter2. That name is a little bit less descriptive because it doesn't say who's the from and who's the to. And in my opinion, it's a few too many temporaries, because if we rewrite this, where we just say get intersection position of seginfo.from and seginfo.to, and we store those as our lat long 1 and our lat long 2, the code is shorter, and I think it's easier to read. Okay, so that temporary that was kind of just renaming seginfo.from and seginfo.to wasn't really aiding clarity. I think this is more clear. Okay, we can use a bit better names here. We could call this, instead of lat long from and to, we could call it position from and position to. It's probably better in a couple ways. We know which one is the from and to, in case that proves to be important later in the code. And I probably like the name pause for position better than lat long. So, but that might be a judgment call. Okay, so one last temporary. So is this length temporary doing anything very useful for us? And probably not, right? So we call a function that's pretty easy to understand. Find distance between 2 points. We pass in 2 positions, and we get a length, and then we immediately return it. So this temporary doesn't really help me understand much. So I could just write it like this. Return find distance between 2 points of pause from to pause to. And this function now looks significantly shorter, but the lines aren't doing so much work that they're hard to read. So I'd say this function is now significantly easier to understand. Okay? All right, so who's with me so far? Do you think it's been made more clear by removing those temporaries? We got rid of a couple of them, right? We used to have a temporary for this, and we used to have a temporary for length. So that's gone too. Now the code's shorter. Okay, so see at least one yeah that looks more clear. And yeah, I think it is more clear. Okay, so maybe this means we just eliminate all temporaries. Okay, we still got these temporaries, position from and position to. We could get rid of those. Okay, so let's try to get rid of those. So now we say we're going to return find distance between 2 points, get intersection position of our seginfo.from, and the other point is get intersection position of seginfo.to. So this says we've got 2 points. One of them is coming from this function call, the other is coming from that function call, and then those values are immediately being passed into this function, which will find the distance between those 2 points. Okay, so is it shorter? Yeah, it's maybe a little shorter, not much. Went from 3 lines of code to 2, but it's a little shorter. What do you think? Do you like this better? Or do you like this better, which has the temporaries? Okay, so I see one person voting for the temporaries. Any other votes? This is the one with temporaries. Okay, another person says yes. Daniel's joining in. This is the one without temporaries. Okay. Anybody else have an opinion? You like it with temporaries or without temporaries? So that's without, that's with. So personally, I like it better with temporaries. Yeah, I like so 2 people voted on this, so thank you. And I actually like this one too. I find the temporaries help me here. The reason is once I get into really long lines of code like this, where I have, I'm calling functions, they're returning values, I'm passing to another function. Unless those functions are really easy to understand, and really well known, this can start getting hard to understand because you have so much happening on one line. The temporaries, if you give them good names, the temporaries do tell you what are my intermediate steps. So I like it with temporaries because of the fact that with good names, they name your steps. The other thing they do is when you're using the debugger, you can single step through your code, and hopefully you're doing that. So you really want to learn how to use a debugger because you'll be a lot more productive at making programs work. And in the debugger, you can set breakpoints at any line you want. You can step over one line of code at a time. When you have a whole bunch of work being done on one line like this, single stepping through it is kind of a pain. If you tell the compiler to advance one line, a whole bunch of stuff happens. And you can't really see what happens, or it's more difficult, right? So on the other hand, this code, you can tell the debugger, okay, execute this line, and then it'll be stop here. And you can look at what was pause from, and then you can say, okay, execute the next line, one more step, and you can now look at pause 2, and then you can say, okay, execute one more step, and you can basically see what was returned. So the temporary variables make it easier to single step in the debugger, whereas you have a whole bunch of stuff happening on one line. It's not impossible to see in the debugger, but it basically takes some additional typing and care to see what the steps are. Okay, so let's look at what we got overall. So this was where we started, and this is where we ended up. So start was not awful, but what we have after does look quite a bit better. Better variable names, better vertical spacing. We've actually got fewer temporary variables, and that's helped us shorten the code and be more direct. It does look significantly easier to read. Okay, let's talk about comments. So that was like how you structure code. You want comments. Most code is under-commented. When I was at Altera, we actually had someone on my team wrote scripts to just figure out what fraction of a file was comments for every file in Quartus, the big CAD system we're working on. And we found that files that had less than about 25 or 30% of the lines were comments, it correlated very well with people finding that a difficult file to understand, like a difficult .cpp file. So comments really do help you if you write them well. And most programmers don't comment enough. They think this will be obvious to someone else, but it isn't. So what do you want to do? You want to describe the overall structure of your program and data structures. So kind of the big picture. Describe why you made certain design choices. Describe what the goal of some code is. So I have a function. What is that function supposed to do? If you have tricky special cases or your algorithm is kind of complicated, then describe that. Things that wouldn't be obvious from reading the code. You should try first to make the code clearer. Sometimes you do need a tricky algorithm and you have to describe it. But if your code is just hard to read because you haven't structured it well using the techniques we just talked about, try to make it clearer first. Don't leave commented out code in your project. So Git has all your code history. If the code used to exist, someone can always go back and get it. So don't comment out some code that doesn't work anymore or nobody needs because it's in their way. It's like visual clutter, and they can always get it back if they need it. Don't translate code to English. Okay, so don't write in top of a for loop, for int inter ID. Okay, so don't write above that for loop over intersections. That should be pretty obvious from the code. You can tell me why are you doing a for loop, why are you looping over all the intersections, or what's the whole purpose of this for loop, but don't tell me that this is a for loop that's going through intersections and that's your whole comment, because I can tell that by reading the code. Okay, you don't want to duplicate code either. So it's a sign of poor coding because it can probably be extracted in its own function. It was also probably copy pasted by the programmer. So when you duplicate code, usually you take some code, copy it, change a few variables. So the code is now longer, so it's harder to read and maintain forever. And that copy pasting, you might have forgotten to change one of the variable names or one of the if statements, so it's a frequent source of bugs. So here's a piece of code, and don't really worry about what this does, but it's actually something a piece of code from a possible milestone one function. And it's trying to basically create let's see, let me read this quickly. And it's trying to create a intersection street segments. So it's trying to create a list of street segments or a vector of street segments for every single intersection. Okay, and we're storing them by intersection. So that's what this is doing. We're saying put in the vector entry for a certain intersection, and then we're indexing it from by the street segment from ID. I want you to put this street segment ID in that vector. And I only want you to do it if there wasn't one in there already. Okay? And then we have code down here that looks very similar. So a street segment has two endpoints. Okay, it's got a from, it's got a to, and basically this code is looking at both endpoints. They're both intersections, and it's doing essentially the same thing for both of them. Grab that street segment ID. Okay, so this is our street segment ID, and put it in some vector, as long as it's not a duplicate. And there's a comment saying, okay, make sure it's not a duplicate before we store it. So at least the person has commented. Yeah, and I see Dante saying this is so hard to read. It is hard to read, actually. Even as I know what this does, and even as I'm reading it, I'm like, huh, this is kind of a pain to read. So, what could we do to make this easier to read? And you're not going to understand everything in this because I am showing you code where I'm not really giving you any context. So yeah, comments will help. What is the indentation? Let's see. Yeah, this is actually poorly indented. This should really be indented more. So yeah, this person didn't do it. Whenever you have to extend a line, so this is basically one big function call, I should have indented this line a lot. Like, so actually, yeah, my TA would really beat me up for this because the indentation is pretty bad. So it's probably an artifact, partly of making the slides. But this is poorly indented. This should have been moved over a lot. Anything else I can do? Okay, so I'm going to show you one thing you can do for this. So yeah, we have this duplicate code. So aside from the indentation problems and so on, and maybe I should have more comments, the most fundamental thing about this is I have almost the same code twice, right? I've taken this block of code and I've cut it, pasted it, and I've basically changed this SS from to SS2 all over the place. Okay, and I really don't want to do that because I have to read twice as much code now. So let's say that I extract it into a function. So if I extract it into a function, this looks a lot shorter. And you're right, I actually have to go and fix the indentation here. Okay, so I'm getting bad marks for indentation on this because that's not really indented enough. I've extracted this into a function, so it looks shorter because I just see two calls to this function now. The other thing is I've given a name to that function. So now it gives you a hint. What am I trying to do? So this was basically checking, is this particular street segment ID already in my vector? If it's not in the vector, then put it in. Okay, that's what it's doing. Well, it's a lot easier to read that if I just give it a name. So insert unique is put it in if it's not a duplicate. And now you see that called twice. So shorter, and the function name helps you understand what's going on. I may not even need to now go look at this function if I'm reading the code. It's like, yeah, I know what that's doing. It's fine. That's not what I care about. Just keep reading. So it gives you kind of hierarchy of information. What do you think of this comment? Okay, so it has comments. There's a comment there, there's a comment there. Read those comments. What do you think of them? Do you like them? Do you think they can improve them? It's definitely better to have this comment, I think, than no comment. Okay, so this is like a trick question. But is this comment as clear as it could be? Or is there anything you could do, you think, to make this easier to read still? Okay, so I'll give you like a few seconds to think about it, and then I'm going to show you what I would do. Okay, so the comment's not terrible, but it's a bit repetitive. It's kind of like the way we had repeated code before. This comment is kind of repeated. Make sure the ID is not a duplicate for the SS from intersection ID. Okay, make sure the ID is not a duplicate for the SS2 intersection ID. Well, okay, so it's almost the same comment. Why did I write it twice? Okay, Andrew's saying he doesn't like using variable names in the comments. Yeah, that's true. This could actually this could easily get out of date with the code. If somebody just renames the variable, they may not realize they should rename it in the comment. So this is just a local variable. There's nothing particularly meaningful about these names. Probably don't really need to say it in the comment. So what we can do instead is, our comment is supposed to be giving like the higher level context. So the higher level context is add the street segment if it is not a duplicate. And that's what both of these lines do. One does them for the from intersection, one does it for the to intersection of this street segment. This comment is shorter, and we didn't write it twice, but it tells us everything we need to know. And we're using kind of our vertical spacing trick again. So we basically grouped these two function calls, which are basically doing the same thing, just on the two different ends of our street segment. So again, we've got a from, we've got a to, and we've got a street segment ID. So we're doing one end, we're doing the other end. Group those vertically, group them with their comment. It's a bit easier to understand. So the block of code that does this little bit more higher level functionality. Okay, so it's a bit more succinct. It's a bit higher level because it describes two lines. I mean, it's still not a really high level comment, but that's fine. You know, it's a short comment describing how these two lines of code work. Okay, so that's it for the guidance on good code style here. As I said, we'll talk about it a bit more in lecture. So good code style reduces your cognitive load. So you're trying to minimize how many things people have to remember at once, and it explains why you're doing things. So key principles that are keep your functions short, and hopefully that exercise I just showed you, where renaming just even like 2 or 3 lines of code as a function made it a lot easier to understand what's going on. Use descriptive variable names. Limit your variable scope. So don't use a lot of global variables. You have to use some of them for this project, but try to limit how many you use. And for your local variables, declare them right before you use them when that's possible. Your comments should be focusing on the big picture. Why am I doing this? What is my goal? What is my overall approach? Not commenting tiny bits of code that someone could figure out just by reading the code. And don't duplicate code. So if you have short functions, you're going to get a lot less duplicated code. So some of these things go together. If you find you have duplicated code, it means you need to refactor. So refactor just means, editing, rewriting. Happens all the time in coding. It's just like writing essays. You don't write an essay in one draft and say, I'm not going to change it. Code, it's even more prone to editing and rewriting. So you refactor code all the time. The requirements change, you add new features, the code starts getting messy. You sometimes think of a better way to do it. So you go back and you extract code into functions, you reorder some things, you make it clean again. And if you don't do that, code tends towards essentially chaos, right? Like in large programs, you need to set aside time to do this, or your code quality gradually goes downhill until nobody can figure out the program anymore. Okay, so some additional resources. So here are a few books that you could go and read. Online resources. So Google has a very extensive style guide, which is quite good. Some of it is going to be, it's more than you need, right? Because it goes through all sorts of details about how to write good C++. So it's interesting if you have the time to read it. I wouldn't worry about some parts of it. You go, wait a sec, this is really detailed about some particular part of the language I don't understand. Yeah, I wouldn't worry about that. But there is a bunch of good high-level advice in here as well. And lots of detail. So if you want to see a bunch of detail, go for it. In creating your code style in this project, we're not going to go for this kind of, like most companies have a very detailed coding style. We're not going to go look at that level of detail because you can start getting in debates about, wait a sec, is this style better than that? We're going to be looking for things that everybody agrees are good, which is basically what I had on this slide. And that you won't find anybody who disagrees with these goals for style in any language. These are kind of fundamental principles. So that's it for today's tutorial. I'll hang around in case there are any questions.